Good afternoon, everyone. This is Mark with Wear Parts, and with me I've got Eric Derry on our inside sales customer care team. And what we wanted to talk about today is cold metal transfer hard facing. It's a unique hard facing method that's used exclusively by Wear Parts, and we hard face many different wear parts using that method. The only material that we don't hard face is the high chrome castings. But tell us just a little bit, Eric, about the cold metal transfer process.
Well, the cold metal transfer process, it's you start out with a wire. It's looks a lot similar to like a wire feed welder, but within that material there are carbides in there. So as you apply the material, you're basically laying down a bead of hard metal that actually has carbides in it. The nice thing about cold metal transfer, well, there's actually more than one thing that's nice about it. Number one is that you can do it automatically, whether it would be a robot or some other kind of semi-automatic application. It works real well for that because you are doing a controlled arc. You can set that up and just have that robot run down, lay that bead in there, and so that your manpower demands are much lower. That's definitely an advantage right there. Another thing is that the cold metal transfer, right in the name of it, is cold. There's not as much heat input, so you're not putting as much heat into the part or the material that you're adding. Just enough to melt it, but you're not diluting that metal, so any of those carbides that are formed in there, they're not going to get spread out, they're not going to be reduced. That hard metal is going to stay hard, the base material is going to stay in the base material. So you'll actually see that metal standing up on top of that base material. So that reduces the amount of dilution that you have. And another advantage of that cooler temperature is you have two different shrink rates. You get two different types of metal here. The base material is going to cool down and heat up at a different rate than what that hard metal is.
It makes sense.
So as temperatures are changing, heating up, cooling down, if the difference is too much, then you could have cracking in either that hard facing or in that base material. On
the varying degrees as it cools down. So this cold metal transfer, your heat, if you check the heat directly after you've ran this bead, it's running 400, 500 degrees, whereas like your standard hard facing methods, whether it's oxy-fuel or CV welding, you're running up 1,200–1,500 degrees of heat, so a lot more heat. So, and we've done testing on the base material, like this boron steel sweep here is 48 to 52 Rockwell. Before we start, we take this back to the lab and we test the hardness of the base material after the hard facing hasn't changed. It's still at that 48 to 52. Whereas if on other methods, when you're running that heat so much higher, it actually pulls some of that tempering out.
You end up with softer spots along that in that base material that's going to actually wear out faster.
So what hardness is this cold metal transfer?
If you're looking at a base material here, like 48 to 52 on this heat treated boron, that's pretty high. When we get into start putting this hard metal on the edge, then you're getting up into the upper 50s.
I was thinking of just looking at the specs before, 58 to 62. So it's actually around 10 Rockwell harder on this edge than this sweep itself. And like I said, here's some examples. We do this is a big furrower. It's got the cold metal transfer along the edge here, and then it has an oxy-fuel nose because that's such a big nose. You need that heavy-duty oxy-fuel. Here's an Alabama sweep. It's got cold metal transfer. That's an 1¼ inch wide bead there. That's used in Arizona, California market. And here's a peanut blade. Tell us about that, Eric.
This is a peanut digger blade for harvesting peanuts. And you can see right here, this is a perfect application for an automatic or a semi-automatic, being able to run this big long bead all the way down, and then being able to do this nose separately afterwards. So having something of that length to try to do that by hand, you're going to be exhausted.
Oh, it is. It's very fatiguing to try to do that by hand. So that's where doing that automatically is much nicer, and it has a nice uniform bead. That's one thing that folks want with the hard facing of a tillage tool is they don't want that bead to be really tall.
Right.
They want a shallow, wide bead. Is that right?
Yeah. Thin to win is a good way to put that.
That's a nice one.
Yeah, you just want that on there. You want to have that protection from the hard facing, which is why the cold metal transfer with the less dilution makes a whole lot of sense. Even on a small cultivator sweep like this, where you have this nice little edge protecting that edge right there, and then even on the tip here, you can see right here where this was actually done with cold metal transfer also.
Yeah, being that nose is quite a bit smaller, we use a CMT cold metal transfer method for that hard facing on the nose as well. And that's a fertilizer knife over there. That's got the CMT hard facing along this leading edge of the fertilizer knife, and then also along this bottom here. That's good. Thin to win. That's good. That's what the folks that run the marathon. That's how they come out ahead. Is that they're stay thin to win. You got to be thin to win it. Well, that sums up our talk today on cold metal transfer. And if you have any questions, please reach out to our sales team and our customer care team for any requests that you may have on the cold metal transfer. Thank you very much.